Extreme Calculus.
Hi, you're here with Extreme Calculus. My name is Tyson, and this is my associate,
Bruce. Today we're going to be talking about what makes calculus so extreme and interesting.
For those of you who don't know, we take callers and answer their questions. We also have a special guest star, Dr. Rosenberg.
So don't nobody go nowhere.
Odor blocker body wash is so powerful it can block BO for 16 hours. It's so powerful it can turn off the sun. But then it gets too cold, so it makes another sun. Double sun power! Power!
We're back with Extreme Calculus.
That's right, my name's Tyson Hulk. Yeah!
And for those of you who forgot, I'm Bruce Axel. And today we have more calculus than your body has room for.
It's gonna blow your minds. Let's take our first caller. Hello, first caller. You're on the air.
Hi, I'm a first-year student at the University of Math 251, and I have a question.
Yeah, shoot, bro.
Okay, so I was wondering, what does a derivative have to do with math?
It's a pretty extreme question.
That blew our minds. Let's give it to the HAL 3 billion.
A derivative is a mathematical term used to essentially describe slope. Thus the words of slope and derivative are in many circumstances interchangeable. So if you take a function f of x that equals x squared and graph it, you would get the following curve. The slope at any given point is the derivative at that point, because that is what a derivative is. So at x equals 1, the slope or derivative is equal to 1 on this particular curve. To find a derivative, you take the function and put it through the power rule. With this particular function f of x equals x squared, you subtract 1 from the exponent and move the 2 down to a coefficient. This gives you 2x to the first power, or f prime of x is equal to 2x.
I hope we were able to answer your question.
Stay raw, dude.
Alright, let's take our next caller. Hello, you're an Extreme Calculus where calculus grows arms and punches you in the face.
Hi, I'm in the middle of one of my midterm exams right now, and I need some help on one of the questions.
Turn the main up, dude.
Okay, so I have this velocity function, and I need to get it to an acceleration function.
Alright, first of all, here at Extreme Calculus we do not condone cheating. But if you're not cheating, you're not trying hard enough.
Let's take this to the HAL 3 billion.
The relationship between velocity and acceleration functions is a very fundamental question that harks back to the sole purpose for the creation of calculus. Given a velocity function v of t and an acceleration a of t, and although we won't be going into it, a distance function s of t, the acceleration function is the first derivative of the velocity function. That also means that the integral of the acceleration function equals the average velocity.
Thanks for the answer. I'm definitely going to get an A on this for sure. I gotta go really quick. Wait, no!
Mega Kill. Massacre. Killing spree.
That was pretty extreme.
Hell yeah.
Alright, let's go to our next caller.
Hi, you're an Extreme Calculus.
Hey, Extreme Calculus. My name is Adrian, and just after I woke up this morning to feed the horses, I was wondering how much I had fed them over the prior week, when each day of the rate corresponds to the function f of t equals sine t pi, when 1 week is 1 period.
Wow, that was a pretty extreme question. Another one for the HAL 3 billion to answer.
Given that the function f of x equals sine pi x represents the rate at which you fed the horses over a 6-day period, the total amount of food that you fed them is equal to the integral of that function from 0 to 6. This is equal to 0, which means you have fed them nothing over the entire week.
I gotta go.
Sounds like he's got some stuff to take care of. We're gonna take a quick commercial break, so don't change the channel, or else I'm gonna...
Old Spice odor blocker body wash. Black, 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 black odor for 16 hours. Power.
Welcome back to Extreme Calculus. Today we're talking with Dr. Rosenberg all the way from his hometown in Prussia via our ultra-fast fiber optic network.
That's right. Dr. Rosenberg is going to be talking to us about something totally extreme, that's for sure.
Yes, it's very great to be here. It's a real honor to be on the show. Well, thank you for having me.
Don't fret, broski.
Well, I'm here to talk about Lagrange multiplier. Now, let's say you have a three-dimensional function, x, y, and z. If you were to take the partial derivative of that function for every variable, and relate them with a multiplier, you could. Well, it's like finding the steepest and fastest way down a hill.
Actually, Doctor, that's incorrect. The fastest way down a slope is with rockets. Yeah!
Well, no, that's not actually correct. I mean, it would work the same with or without rockets, you see.
Sorry, Doctor, we're gonna have to cut you off right there.
That was so extreme, I'm going to turn myself into fuzz for arson.
We have just enough time left for our fourth and final caller.
Hey, you're on Extreme Calculus.
I called last week and you didn't phone my call and I'm very upset.
Well, that's all we have for today. But don't forget to join us next time when Extreme Calculus goes chemical!